So X grams of water, so that's like 0% acid, 80 grams of some percent acid, and that's result is 1/y times the Q percent, the initial concentration, because that's the concentration that the 80 grams had, which we don't know. We add some water to that to be 1/y times the initial concentration. Okay, so we want to know what Q is. So number 1 tells us X equals 80. So that means there's equal weight between the 0% and the Q percent. Basically, if there's equal weight between these, then the overall average should land right in between. But the problem is we don't know if this is 0 and 80 and this is 40, or that's 0 and 60 and this is 30, that's 0 and 40 and this is 20, different. It would just land halfway in between, really, because it's 0. Yeah, so that's not sufficient. Number 2, y equals 2. Okay, so the overall combined concentration is 1/2 of the original concentration. So, but again, we don't know if this is 80 and so that's 40, or this is 60 and that's 30, this is 40 and that's 20, so that's not sufficient. Now putting together, this is tricky, but notice that putting together is still not sufficient, because we kind of already knew that the overall, it was going to be half the concentration, because this was 0 here. So, and because there's equal amounts, 80 and 80, the concentration is going to land halfway in between the two. And so we still don't know if this is 80 and so this is 40, or this is 60, this is 30, this is 40, and this is 20. So that's still not sufficient. If this hadn't been 0% here, then I think we could figure it out, because it would have to be in such a state as where being half of Q also lands right in between the 10% and the Q percent, or something like that. But because the X grams of water, the 80 grams of water is 0%, and then there's equal weight between the 0 and the Q percent, it's always going to land halfway in between. So number 2 actually adds nothing to the picture, so combining them is still not sufficient. E.